class. Okay. All right, guys. Okay. All right. So let's talk about the conjugate gradient method. Right. Guys, let's say that we have a function f of x, and this function where x can be a vector, not just a scalar quantity. So x, again, x could be a vector 1, 0, 2, 3. All right, it can be a vector. It's not necessarily that it is a scalar. So the function is 1/2 x transpose a x minus b transpose. طيب. We need to find this x. We need to find this x that it minimizes, which minimizes this function. Okay? We need to find this x which minimizes this function. Now, in order to find the minimum, what do we need to do from calculus? You studied that. What do you need to do?
Derivative equals 0.
You need to find the derivative, right? And you need to equate it to 0, right? So if you take this function and you take the derivative of this function with respect to x, you will end up with ax minus b. Isn't it? You will have ax minus b. And in order to find the minimum, we maximize it over here. In order to find the minimum or the maximum, you need to equate this quantity with 0. Right. Does that remind you with anything over here? Isn't it that we are trying to find the solution of a linear system?
Yes.
We need to find the solution of a linear system. Okay. Let's try to visualize something of that form. So let me switch to MATLAB. Okay, let me switch to MATLAB. And the command window, I think I can bring it over here. And the command window, let me define whatever system, A, 2 by 2, okay? And let me define the B vector, okay? And let us define, guys, this function which we just talked about. That is the function half x transpose A times x. It is exactly that function, okay? So we define that function, and let us now try to plot so we'll have something like that. Okay. Now, based on what we discussed 1 minute ago, where do you expect the solution to be? This is x1, that is x2. شباب وين تتوقعون يكون السوليوشن؟
x1 would be between -2 and 0.
x1 will be
x2
and 0. So okay. So what I think, Ali, you are trying to say is that the solution exists somewhere there, isn't it?
Yes.
Why? Because that is the minimum value of the function, isn't it? So basically, guys, if we started at certain point, okay, the task is to go into that direction to find the minimum quantity. By the way, these contours says that the value across that line is constant, okay, and the value across this line, if you project that line over here between x1 and x2, and you project it on this plane, this is constant. So this is just a projection for the constant values on that surface. Okay, so guys, based on what we have seen, we need to minimize this function, and this function as we can visualize it, right? And we need to find its minimum. طيب. In order to do so, let's define the following. We will say we will choose a step length. يعني each time while we are trying to search for the problem, notice this is an iterative method. ايش معنى iterative شباب؟ Iterative means you cannot jump into this final solution into one shot. Maybe it's possible under certain circumstances, but the issue is you will go in one step, then another step, then third step, then fourth step, and fifth step, and I don't know how long it will take you in order to reach the final solution, the solution which satisfies the conditions that you have. Is that clear? That's what we call it iterative. You iterate, you take one iteration, second iteration, third iteration until you hit the local minimum. Okay? So I will take a step length alpha k. The k guys stands for iteration number. I'm at iteration number 1, then I will go to iteration number 3, then iteration number 4 until I find the solution which minimizes the error. طيب. A step length that minimizes f of x k plus 1. يعني at the next iteration, I want to minimize that thing. Remember, what is the solution? The solution is minimizes that function. That function. And from the plot, one more time, we can see visually that that solution that minimizes this function is around 2 and something around 0 from x1 and x2. Is that clear? Shabab, visual. Can you visualize the problem right now? Give me a thumbs up if you can follow what I'm saying.
واضح دكتور.
واضح. Okay. At least 2 people responded, and the rest are 3. That's it. So if I call Hadi and Khalid and Muhammad and Ahmed Ala and Anas, are you following me? Mustafa, Nasser. Right, so let's define the following now. Let's define something called the residual. What is the residual? Basically, it is B minus AX. The residual, let's say I have a matrix. I think I need to make it smaller even. Okay, let's say I have a matrix 1, 2, 3, 4. Okay, and I have a B vector 6 and 7. Okay, that is B. So xk, it's an initial solution. So suppose I started with x, at the initial iteration, 0 and 0. Do you think this satisfies the equation? Let's see. We will have, let's define it in MATLAB. Switch to MATLAB. Let me enlarge this stuff. Let me clear the screen. Let me define A. Okay, I think I already have A and I already have B. So, and I will define define x to be 0 and 0. Okay, so now what is the residual? The residual basically says it is B minus A times X. Okay. -2 and 4. Shabab, when do we say that we obtain the solution? When do you think can we
When
say
when R equals 0.
when R equal to 0? Exactly. شباب, when R equal to 0, this means I need to write on the screen. Okay. When when things do not work, then they don't work. Yeah, we cannot do anything about it. Yeah. Now it refused to work. Okay. When R equal to 0, this means B minus X equal to 0, which means that I cannot write it here, which means A times X equal to B. Shabab, didn't we do this exercise previously? We said A times X minus B should end up with zeros, isn't it? While we did the Gauss and the Doolittle.
Yes, it was a method to check the solution.
It is a method to check whether the solution is. So basically, Shabab, our task is to find a residual and minimize this residual, right? If this residual is approximately all around zero, then we can say that we had the solution. That solution is the minimum that we are looking for. طيب. Now, I need to erase all this part. Unfortunately, I cannot write on the screen right away. So, okay. So, what are we going to do? We will define certain step length. Okay. I will say that A times xk plus alpha s. What is s? S basically about the search direction. Let us bring it back. Shabab, where do you think which search direction I'm going to write it on the screen or using the cursor? Do you think, Shabab, this search direction, if I start at that point, is this search direction better or this search direction better?
the second one.
The second one. Why? Because
it's getting closer to the solution, to the minimum point.
طيب. So Shabab, this is what I mean by the search direction, S alpha, and alpha, sorry, by S, and alpha is the step size. Yani you can go in the right direction, but you can go in the right direction at this step, or you can go to the right direction at that step. واضح الفرق؟
دكتور تقدر تعيد آخر نقطة ما فهمتها؟
Okay, we said S and alpha. S is basically the search direction. We said this direction is way worse than this direction because this is leading you to the local minimum. I need to write on the screen. So أعطوني بس ثانية واحدة. أحاول أصل مرة ثانية. البرنامج مرة ثانية. Let's try to switch it on one more time. Switch it on one more time. Okay, Bismillah. All right, good. S, this is search direction, and this is another search direction. And you told me that S2 is better than S1 because it's pointing to the local minimum. Perfect. Then I say we have alpha. Alpha, guys, says either you go at this step length, or alpha 1, or you go at this step length. Which one is better? Of course, the second one, because it is reducing the amount of iterations needed, correct? So that is the difference between S and alpha. S is the direction, alpha is the size of that direction. All right? So let's proceed now. Okay, so if you don't understand the mathematics, that's fine. But what I'm doing, I'm defining A times X plus alpha SK, and I'm saying that this is equals to B. I am expanding this this part. I'm expanding this part of the equation. All right. Then I will take. Sorry. I will take AX to the other side, and I will say that alpha AS equal to that stuff. All right. Do you remember that this quantity is the residual, which we defined earlier? B minus AXK. That is the residual. So alpha times A S equal to the residual. What I'm going to do, I will multiply both sides by S transpose. S transpose. Remember what is S transpose? It's a row vector multiplied by a column vector. So this is S transpose, that is R, okay? So what is the end result between this multiplication? This is 1 by n, and this is n by 1.
1 by 1 scalar.
It's a scalar quantity, right? That multiplication is a scalar. This multiplication again will lead you to a scalar quantity. So at the end, Shabab, the step size equal to that formula. All right? It's the surge direction, the transpose of the surge direction multiplied by the residual divided by the surge direction transpose times A times S. Is that clear? So basically, this is the derivation. I will not ask you how to derive it, okay? This is basically the derivation. We'll use this fact, okay, in order to come up with the steepest descent method. So, Shabab, the steepest descent method, what does it do? We go in this way. We go in this way. Suppose we started at that point. We go in a way which is perpendicular, okay, to the contour. And if you think about it, that this is the plane. So this direction is the steepest direction. The steepest direction. أكثر اتجاه في انحناء. Okay? That direction, Shabab, is not steep. Can you see it? This direction is not steep. Maybe this direction is even constant. Yani the value of the function is not changing. Okay? But we can see that this direction is the steepest. Right? If you think about it on the 2D plane, if you project those rings which have constant values, you will project them in this way. So the steepest direction is always perpendicular to the contour lines. This is the steepest direction. This is the steepest direction. That is the steepest direction. أهم شيء إنه يكون دائما متعامد على الكنتور line. Is that clear? I'm spending some time such that you visualize it and you understand it. No response.
Okay, Dr. Clear.
Okay.
For me, it's clear, Doctor.
All right. Yeah, let's continue now. So what do we want to do with the steepest value now? Okay, so guys, the steepest descent says we will go perpendicular to or in the steepest direction. Okay, we will go in the steepest direction. We will go in the steepest direction. Let's say I started from this initial guess. I will go in the steepest direction with what? With certain alpha 1 and the direction of S1. So that is S1, and this is the size of the step size. Then, once I reach that point, I will go into another step size at this direction, into this direction. So this is alpha times S2. Then I will go again in the steepest direction, which is perpendicular to the contour. Then I will go to the steepest direction, steepest direction, until I hit the minimum, the local minimum value. If you want to see it in MATLAB, if you want to visualize this stuff in MATLAB, I will run this code, which let me start from the scratch. Where is the initial? Let me erase everything. Okay, good. Okay, so guys, we started at that point. Okay, we will calculate alpha, we will calculate the search direction, and this is the plane of the search direction. And you can see, guys, you can see that at that point, this is the perpendicular direction to the contour line. All right? So, and we will go at a step size of alpha 1. Okay, let's do that. And then, yeah, let me bring it here. And then let's go in the other direction. The other direction, which is again perpendicular to the contour line, okay? We will calculate alpha again, alpha 2, and we will hit the new solution, okay? I will calculate the residual. Is the residual small? It's not small yet. Let's do one more iteration. Shabab, you will see that it is again perpendicular to the contour line, okay? And I will go at certain step size, which is that alpha. Is the residual small? It is not small yet. Okay, I will do that operation again, and again, and again, and again, and again, until I hit the final solution. The final solution is around that point, and it says that it took us 9 iterations in order to find the solution. This is Shabab, the steepest descent. The steepest descent method is a method which is slow. Okay, it's a slow method. Every time, in order to update the solution, the new solution equals the old solution plus alpha s. Right, Shabab. So, how to code that in MATLAB? How to write a code that describes this method in MATLAB? Let me open a new live script. Let's bring it here. Let us, do I need to maximize it? Maybe I will put it on the side. Maybe I will put that thing over there. I don't think I need to write on the screen. So let's do the following, Shabab. Let's define certain A. Okay, I think I need to a little bit increase the size. Let me define A. A is can I copy this stuff, Shabab? It will save me some time. I will copy A and B. I will again define let me open a new section. I will plot this. I will plot this function, the quadratic function, which we defined it over there. So let me run this code. We have A and B. I think maybe I will put it in line. That is A and B. That is the function, and this is the plot for the surface or for the function. Now, what do I need to do? I will define the following. This is ignore the warning messages. I will define n, which is, or you know what? I will say initialization. I will initialize a few parameters for this problem. Okay, I will initialize a few parameters for this problem. Okay. Okay. At the break, I will copy this stuff and be in this part. Then I will add a code, and this code I will define and it will be the length of B, all right? And I will define X, which is, Shabab, initially, it is the initial guess, zeros. So what is 0, guys? What is this function?
It returns back a 0 matrix.
0 matrix or 0 vector. Here it will return what, guys? It will return 2 rows and 1 column, isn't it? 2 rows and 1 column. 2 rows and 1 column. And this is the initial guess. Okay, this is the initial guess in order to solve the problem. Right. What else I would need? I will need to define the residual. What is the residual? B minus A times X, isn't it? A, okay, let us run this section. It is -2 and 4. What does that mean? Do we have the solution?
No.
Not yet.
No, not yet. Fine. Next, I will say that you will start on this spot that the search direction equals the residual. Okay. What else I'm going to define? I'm going to define a counter. Initially, the counter K, which will go from 0, 1, 2, 3, it starts at 0. Right? And I will define the error, which is norm of R. Okay, norm of R. What was norm? We discussed norm previously.
Magnitude.
Magnitude. Okay, it says that the size of the length or the measure of this quantity is 4.4. When do we say that the error is small?
So when the magnitude is very small.
0.
Okay, so we have to put a criteria. So you know what? Let's define a criteria. This criteria is called tolerance, and this tolerance is 1 to the -4. So if this error is less than 1 to the -4, then you are satisfied, or we are satisfied, right? So this is a quantity which we defined. Okay, we initialize the problem. Let's create a break. Okay, let's create a break. Now let's try to code the steepest descent method. Right. Let us put I will call it steepest method. Okay, the steepest descent method. Then, okay. So we will say that X the old solution equals basically I'm storing the old solution. Okay, then I need to calculate alpha. How to calculate alpha, Shabab?
We have the formula.
We have the formula. So what did the formula say?
SK transpose times RK.
So S transpose times R, okay, divided by
S transpose times A
times
times
A
S.
times S.
Yeah.
Okay, guys. You know what? Let's calculate. Let me run this section, and we found the value for alpha. Okay. Okay. So we calculated alpha. We know S. Okay, and we know. So guys, let's update the solution. What was the new solution? What was the new solution?
The old solution plus alpha times S.
So basically, the new solution x equals x plus
alpha times S.
times s. So guys, let's calculate the new solution. Run this section.
دكتور it's old.
لا ما تحتاج لا. بس you basically are updating the solution. يعني you are overwriting the solution at every time step or every step. Okay.
So we don't have to store the old value.
We don't need, but يعني this is just to say that this is the starting point.
Okay.
For reference مو مهم بالنسبة لنا حاليا. Okay. Then what else do I need to do? I need to update the residual. What is the residual, Shabab? You can see the residual.
B minus
AX.
Okay, so let's update the residual. Basically, it is equivalent to saying R minus alpha times A times S. Where did I get that from? From there. The residual basically is that quantity, okay? R minus alpha times A times S. Basically, the new, what I'm saying, the new residual equal the old residual minus that quantity. All right? So let's see how much is the new residual. Run this section. The new residual is that quantity. Of course, I need to calculate the error, which is based on the norm, right? So the error equals norm of A times X minus B. Okay. So let's see what's happening to the error. Run this section. It is 4.8. So it did not, I'm not sure how much we started with. Where was the 4.4 something? 4.8 did not decrease much, right? So what else do we need to do? We need to update the search direction. So the search direction equal to R. Okay, the search direction is equal to R. Alright, أعتقد شباب أحسن الحين إن أسوي put the solution on site. Okay. And over here, guys, over here, I don't want to display this quantity. I don't want to display that quantity, neither the norm nor x0 nor n. Okay, alpha, right, okay. Okay, and you know what? Let's just ask MATLAB to. Yeah, we skipped one item. We skipped basically updating the counter, right? So the count equals count plus 1. You are increasing the number of iteration every time, correct? So initially at count equal to 0, that was the initial guess, right? So what at the second iteration, or in this case at the first iteration, this is the new solution. So you know what? Let's just print this quantity on the screen. So basically, in this command, what I'm saying, fprint, it's a MATLAB command. Okay, k is the iteration, and I will put the count inside that location, and I will print the error at that location. You can read more about the if print in the help file. Okay, this is just a way to print the values on the screen. Let me clear everything. Let me run this code one time. We have the plot, and this is, guys, the first error. At the first iteration, that is the error. What shall we do now? What shall we do? Let's run it again. Let's run this code again. So I will run it again, and this time, okay, I will run it again. So guys, at the second iteration, this is what's happening to the error. Can you see what's happening there?
The error is
It's
decreasing.
The error is decreasing. Okay, you know what? Let's run the code one more time. I assume I can stop that part from showing it on the screen. Let's run it again. At the third iteration, that is the error. The fourth iteration, that is the error. The fifth iteration, that is the error, and so on. And if we keep, the error will decrease and decrease and decrease. Is that clear, guys?
Yes.
Yes.
دكتور
Yes.
نعم.
الايرور steepest descent method norm ax minus b او b minus ax اللي هو الار norm تبع الايرور.
The norm is a length of a way of finding the length, right? So b ax minus b, b minus ax.
Doesn't matter.
It doesn't matter. Yeah. Okay. All right, so guys, if I want to automate the process, هنسوي it, and basically every time. Okay, you know what? This one I can skip this part. Can calculate alpha. I can update s. Let us do it in this way, guys. Let's say that r equal to b minus a times x. Let's start over, guys. Let's start over. Let's clear everything. Let's run this code. That's the first iteration. This is the second iteration, the third, the fourth, the fifth, sixth, and so on. Yeah, I need to just double check if right approach or not, but let's keep it stick to what we have over here. Now we have run it manually, right? So what can we do in order to automate it, to automate the process?
For loop.
While loop.
For loop. Right. What is the difference? I got two answers now. For loop and while loop. So first of all, what is the difference between a for loop and a while loop?
For loop, if we know the number of iterations. While loop, if we have a condition, and our condition here is the tolerance.
Okay. So basically, guys, do we know how many iterations do we need in order to hit the local minimum? Do we know how many steps from the figure itself? Do we know initially how many steps we had taken in order to find the final solution? We don't know that stuff, right? Right? That's why we need to define it in terms of a while loop. While this condition is not satisfied, do the following. Once the condition is satisfied, okay, then stop. So if you want to do it using a for loop, it will say, where is that? Yeah, over here. Then we need to wrap this code between a for loop. So for what? For
I equal 1.
I equals 1 to max or count max, for example, max count. Okay, طيب, do the following. Let's wrap it inside a for loop. Okay, let's end this. Okay, do we have max count? We don't have max count. Let's define it. Where shall we define it? We'll define it somewhere around the count. Okay, max count, let's say it is equal to 3. So 3 iterations. Okay, let's clear everything over here. Run this code one time. So this is the اعتقد شباب المفروض نروي الاشياء لان قاعد تخربطنا. That's it. Clear. Run this code. So this is the first iteration, the second iteration, the third iteration. Are we satisfied with the solution?
Not yet.
Not yet. It should be around in the vicinity of 10 to the minus 4, 10 to the minus 5, based on the conditions that we have, right? So we need to increase the amount of iterations. Run this code again, and after 5 iterations, it is, but still larger than 1 to the minus 5, minus 4, correct? So we need to increase it. So better than doing so, because we don't know how many iterations it will take us, we need to define it using a while loop. We will define the while loop after the break, and then we will jump into the conjugate gradient method. Okay? We will move to the conjugate gradient method after the class. Do you have any question right now, or we can just start the second phase of the lecture?
Sure. Will the formulas be available to us in the exam?
طبعا شباب. You don't need to memorize any of those, of course. Yeah.
Okay.
طيب شباب. I'll see you in 10 minutes. يلا مع السلامة.